So first one, how do we solve for y? Or we can start with something else, but I think y is probably the best place to start. Well, first thing to note is that the two lines through the triangle, so z and x, are parallel to the base. So can we use the side splitter theorem to solve for y? Can we use the side splitter? Yeah, so the easiest way for y is just 4 to 2 equals 6 to y. Or some version of that, you could do 4 to 6 equals 2 to y as well. Okay? And again, that's because z is parallel to the base, and so it splits those two side lengths in a proportional way. So 4y equals 12, and y equals 3. All right, how about z? What's a good way to get z? Can we use side splitter for it? Why not? Yeah, it's not a side, right? It's a base now. So we cannot use the side splitter for z or for x, actually. Yeah. Are these right triangles? So don't use Pythagoras. All right, well, I think for for z, I would do like something like 4 to z equals, so that's on just this little top triangle, I'm doing left side to base. So now we need like whole left side to the other known base, which is 13. So 4 plus 2 plus 6 is 12 to 13. Okay, and that's a quick way to do z. So we get 12z equals 52. So 4 times 13. And then z equals, what is that? 4.33, I think. Is that right? Okay. All right, and then x, you can do a similar thing, actually. So I'll do it down here. Now I'm looking, since x is a base, we can't do side splitter, but I can use this whole left side and say 6 to x. Okay, and then again, the whole left side, just like we did for z, whole left side to the base 13. And so that would be 12 to 13. Should x be bigger or smaller than z based on the triangle? Should be bigger, right? And so we see the same kind of setup. And since this is a 6, yeah, x will definitely be bigger. Room is always an issue. So 12x equals, what is that, 78, I think? So 6.5 for x. How'd you do on that one? What is that? What are you doing? Oh, gotcha. Thank you. Any questions on it? Are these the only ways to do these ones? Okay. All right, let's do this bottom one next. What theorem is this one using? Yeah, that's the angle bisector theorem. And this is good test practice because it doesn't say anything about that in the prompt. And it's just randomly mixed in with the other stuff. How do you know it's angle bisector then? Good. Okay, so we're seeing that an angle is bisected, and so it splits everything else into congruent parts. I'm going to do 15 over y and 7 over x. What else could we do? What's another way to do this? Like another setup, I mean. Just to review the options. Can you give me another one? No, by setting up a different proportion, you thinking of it differently. Okay, sure. Okay, and then we just plug in y. So this first one would be 15x equals 140. Maybe I'll write it 20 times 7. And then what's 140 divided by 15? 9 something. What? 9.3. Thanks. Okay, and then over here I'll use the other one with the 18. So x over 18 equals 7 over 15. 70 and 56 is 126, I think. Okay, how about that one? What was it? 8.4. Thanks. And finally, any questions on that one, I guess, before we move on? The angle bisector is usually pretty easy. The only time it may be not, well, it's easy to set up, let's say it that way. Sometimes the solving might be a little bit more work if this was different expressions of x, so we end up with quadratics in there. I mean, but that's not horrible at this point. We've done it a lot. All right, what's the measure of side CB? It says SAT or ACT question. It's pretty much straightforward application of the angle bisector. Lyra, set us up a proportion that we can use to solve. Cool. All right, and then we just divide. What do you end up getting on that one? Yazzie? Okay. What is 6.4 times 4.2? Did anybody do that?
6.4 times 4.2?
Yeah.
26.88.
Okay, thank you. All right, how'd those go? The last two, like I already asked you about the first problem with the ladder, but what about the others? Okay. By the way, since I saw this, I want to mention this. Do you remember this stupid problem from the book from yesterday? Yeah. And I told you, I like the thinking kind, which I do. I went in and looked at it some more yesterday afternoon. And it turns out that unless you think of it with a very limited view, the way that the problem writer wanted you to, it's actually written wrong. And here's why. I want you to just take note that this can happen sometimes. Let's look at just this triangle. And I'll fill in the values. So if you note, it's 5 and then 13. Everybody agree? Okay, this is a Pythagorean triple, which makes this third side, this whole thing, be 12. So 5, 12, 13 is a Pythagorean triple. Everybody with me? Okay, now watch this. If I focus just on this triangle, what kind of triangle is it also? It's also a right triangle, and that was given, so we're not like making any assumptions or anything. Okay, the side lengths of it are 4, 10. Here's our right angle, and that same side length. Right? Same side length. Well, check this out. Hi.
Hello. Can I do lunch detention?
Yeah, go ahead.
Sweet. Corbin and Ezekiel. Lunch detention in the small gym after this class.
Cool, thank you.
Thank you.
So I'm going to call it Z. That's what I noted in the figure over there. So this one is the square root of 116, right? 4 squared plus 10 squared, that's 116. Which is clearly not 12. So, did we make any mistakes in our reasoning? No. So, basically what I'm saying is this same side within one problem takes on 2 values. Can it do that? So, it's written wrong. Okay? It's sometimes hard to write problems when you're thinking, hey, let's use proportions to solve in here, but also you have some other theory or concept going on like Pythagorean theorem, and you have multiple side lengths, it's kind of hard sometimes to capture every option. So that happens, but that was one issue with why I was like, what's going on with this? It's just weird. Okay? So any other comments or questions on that one? Maybe you'll come across something like that someday. All right, so I think I'll just let you work on the review the rest of class. This is a unit exam, which means all your homework is due. Any missing homework is due tomorrow. Also, as a unit exam, it means it covers everything in the unit. So you need to be able to solve proportions. You need to be able to solve quadratic proportions. Let me remind you what those look like. Maybe it's x plus 2 to 10 equals 2x over 3x minus 1, right? And then when we do our cross products, we end up with the quadratic. So you'll need to be able to factor. You'll need to be able to prove similarity. What are the 3 different ways we prove similarity? Side, angle, side. Side, side, side. And angle, angle. Definitely the angle, angle being the most common. We also did these last 3 theorems. So triangle mid-segment, the side splitter, angle bisector, that will be on there. Right triangle similarity will be on there. And there will be a little bit on the indirect measurement where you might have to draw a picture of a shadow or a flagpole or whatever scenario. Okay? Any questions on any of that we need to review before I hand that out?